All right. Good afternoon, everyone. My name is Andrew Owen. I'm with the OSG Research Computing Facilitator. I'm joined by Justin Heimstra, who is a Pelican platform developer. And today we're going to talk about moving your data with Pelican and the OSDF. So the slides are available as well for you folks if you want to follow along at home. Let's see here. That should be the link. As you notice, we're also recording this, and we'll post the slides and the recording to our website at a later date. All right, so a couple logistics here before we start. We welcome any and all questions, so please don't hesitate to ask. If you're going to ask a question, you can do so in the chat, or you can unmute yourself as well. As I mentioned, the slides are going to be available online. The link is posted in the Zoom chat and will be on our training page in the coming week on portal osghsc.org. Okay, so the goal today is going to be talking about Pelican and the OSDF in the context of the OSPool and high throughput computing. So we'll start off with providing that context. So I'm going to be presenting the first half here, which is going to be talking about the OSPool and high throughput computing, using data alongside of computes, and then the system that we use for distributing data, which is the OSDF. So that'll be more on your user on the OSPool side of things, and you want to move data around as you're doing your computing. Part 2 is going to be presented by Justin. He's going to talk more about Pelican, which is the software that underlies the OSDF, and he'll talk about some of the features involved in that, and as well as how you can contribute your own data for use on the OSDF. Right. So we'll start off with part 1 here, and then towards the end, I'll switch it back over to Justin so he can talk about it. All right, so OSPool and high throughput computing. So hopefully you're aware of the OSG and the OSPool if you're in this training, but if not, the OSG consortium builds and operates a set of pools of shared computing and data capacity for distributed high throughput computing. So it's mostly based in the United States. There's a few contributors that are funded in some parts by US-based projects. And so you see we have quite a few contributors in the US, but also a few elsewhere around the world. So the idea here is that campuses and institutions have spent a lot of money in their own research in developing and investing in local compute clusters. So, universities, Syracuse, San Diego, University of Wisconsin-Madison, they all have put millions of dollars into buying hardware and the infrastructure and the personnel to operate their own research computing. Now, for the most part, that investment stays local, at least for the beginning. But as someone who's investing in building that cluster and building those resources, they like to see it being used. This is where the OSPool is going to come in here. So the idea is, if you spent millions of dollars on these servers and you don't want them to just be sitting there doing nothing, well, then how can you get more work to be done on their servers? And the idea is to work together to pool these idle resources and provide a virtual cluster. And hopefully the way this would work is that, someone at one of the contributing institutions would be able to use idle capacity that's at any of the institutions. And that is fundamentally the idea behind the OSPool. There's a lot of institutions with lots of expensive hardware intended for doing research computing. And when they're not being used, we work with them and they contribute their resources to the OSPool so that anyone who's a member of the OSPool can access those resources and do research computing on those resources. Okay. Oh, I think I dropped a slide here, but OSPool is free to use for US-based researchers. If you are interested, we have more information on our website about how to register an account. Okay, so I'm going to talk a little bit about the size and the scale of the OSG to set some context here. We have quite a few contributing sites throughout the country. We got quite a few that just contribute compute. We have quite a few that contribute just storage, as well as a combination of these things. And you can see it's spread out throughout the entire country. All right, so running jobs on the OSPool using these contributors, this is going to involve high throughput computing. And for high throughput computing, we use software called HT Condor, which is designed for high throughput computing. It starts with an access point, so where you sign in and you have to prepare some information about your job. So the components of the job, what's the software you want to use, what are the scripts you want to use, is there any input data? And you wrap all this information up into an HT Condor submit file. You give it to HT Condor, and then HT Condor is going to go out, finds one of those idle machines that is a member of the OSPool, and it's going to transfer your data from the access points to the execution points, usually in a temporary directory that just exists for the lifetime of the job, runs the calculations, and then HT Condor is going to transfer the results back to the access point, so where you signed in and submitted your job. Now, an important note about this setup is the files that are on the access points are not directly accessible by the files that are on the execute point. So you may be logging in to submit your jobs from a server that's based in Chicago, but your actual calculation may be executing on a server out in San Diego, or may be executing out in New York or Montana or somewhere else. And so that's a completely separate server. Any files that it needs to function needs to be explicitly transferred by HT Condor. And that leads into sort of a problem of scale. So the goal of high throughput computing and the OSPool is to run many, many such calculations. And with that, and HT Condor is designed with this in mind, and we're regularly running 500,000 to 1 million jobs every single day. And if we think about those file transfers that have to accompany those jobs, right? You have to transfer your scripts, you have to transfer maybe input data or some other parts of your job in order for your calculation to function. Well, those file transfers that accompany these million jobs per day total from 1 to 10 million files per day, just in transferring these files. And actually, you can see some of these stats on our website with that. I just grabbed this screenshot last week from the link at the bottom of the slide. Okay, so we are transferring millions of files per day to support the distributed computing that is the OSPool. And another thing we have to keep in mind with that is it's not a short trip. It can be quite the long journey for these files. So returning to that scale of the OSPool, the slide with the contributing institutions, you may be submitting a job from Chicago or from Madison, where our general access points are located. And they could go and run anywhere. So you submit in this location and they could run anywhere. So your files, your jobs are going to have to go out to one of these contributing sites in order to actually execute, and then the results have to be brought back. So let's consider a scenario. We talked about in one day, we're running 1 million jobs on the OSPool. And just for this example, let's say we're transferring 10 files per job. So maybe on the upper end of things. So we're transferring 10 million files a day here. If we think about the volume of data that's being transferred in this scenario, It does depend on what the average file size is involving these files that are being transferred. And of course, every workflow is unique and this average file size is going to vary from day to day. But just throwing out some general units here, if it's just 1 kilobyte per file, that's not a big deal. That's a fraction of a terabyte. The internet can easily handle that sort of thing. But you can see as we jump up in scale, we go up to a megabyte. Now we're talking about 10 terabytes per day. If the average file size is 1 gigabyte, we're talking about 10,000 terabytes or 10 petabytes. And if your average file size is 10 gigabytes, we're talking in the hundreds of petabytes per day that have to be transferred. Just a brief note, this table is using bytes with a Y. Most network specifications are reported in bits, so bits per second, megabits per second, things like that. And 1 byte is 8 bits. So if you want to think about this in terms of network traffic, if you're comparing this to maybe your router at home has, a 10 gigabyte upload download speed or something like that, or sorry, 10 gigabits upload download. You have to divide by 8 to get the value in bytes. Okay, so depending on the size of the files, the volume of traffic of data flow on the OSPool can be very large. 100 petabytes is not a drop in the bucket here. And on top of this, this network traffic is competing with all other network traffic. So everyone who's streaming their Netflix, everyone who's streaming their Amazon TV shows, whatever they're watching, as well as businesses, corporations, all of their data flow. The era of big data is now, and that's a lot of internet traffic. OSPool and OSPool contributors are typically publicly funded, so the hardware that's behind all of these things may not be brand spanking new, and so some of those network switches may be slow, could be filtering or slowing down the amount of data that are transferred out. And the data could be transferred, all the way across the country. If you're logging into a server in New York and your job is running on a server in San Diego, you're transferring that volume of data from New York to San Diego and back. Okay. So small files on the OSPool, those are not too big of a deal. But when it comes to the large files, that quickly scales up the volume when you have large files for every job. And that's where the OSDF comes in. So if we think about what we need for our job to function, usually there is some common set of files. You have an input data set, you have a container file, maybe a reference database, and those files, 1 to 10 gigs in total. So let's think about what happens if we try to submit 1,000 jobs using a 1 gigabyte file for our job. That's not unrealistic. Some containers are, I'd say that's close to an average size for a container, but some can be larger than that. If we think about the OSPool and how it's constructed, we mentioned you can submit the job in Chicago or in Madison, and that could run anywhere. Well, let's consider in the scenario, it runs in San Diego, right? So, or I think runs in Southern California. I'm not quite sure where San Diego is on the map here. Anyway, so let's say there's a lot of idle resources at this university in Southern California, and they're a member of the OSPool, and all 1,000 of your jobs decide to start running on that servers or on that set of servers at the same time. What that means is the first job transfers that gigabyte of data, the next job transfers a gigabyte of data, and so on until all 1,000 of your that is a unit error. That should say totals 1,000 gigabytes, not 1,000 terabytes. My apologies. But if you transfer a 1 gigabyte file 1,000 times, that's a terabyte of data that you're transferring over the network. Hopefully your outputs isn't that size. But yeah, a 1 terabyte is not a small value to be sending over the internet. So we could do it this way, and this is sort of the default approach for a Condor to manage file transfers. But transferring a terabyte of data out of the server in a short amount of time is not ideal. Now, oftentimes, like I said, this is a repeatedly used file. It could be the container where that contains the software that's used to execute your calculation. What if instead of transferring that same file for every single time a job starts, we transfer it once to that same server and then just reuse it, or transfer it to a much closer server and reuse it? So this is where the Open Science Data Federation comes in. This is how we actually manage large file transfers on the OSPool. So the OSDF is a network of storage servers that facilitate this transfer of large files and is especially useful for repeatedly used files that are large. And you can see the contributors in this map here, but I think, there we go. So let's consider our scenario again. You're submitting from Madison, jobs are running in California there. With the OSDF, with the syntax we can provide and tell HT Condor, we can say we're using OSDF to transfer this file. We transfer that 1 GB file to the location where the job's going to be running. And then we reuse that file at that location where it's running, or at least we have a local copy of that file somewhere nearby so that it only has to travel from, say, Los Angeles instead of all the way from Madison. So we reuse that file for all 1,000 jobs, which means in total, we've only transferred a 1 GB total, right? So that's a factor of 1,000 reduction in the amount of data that was transferred for this particular job. And that's the idea behind the OSDF. So a little bit more about the system. The OSDF is a system of origins. So this is the original location of the data. If you're submitting from Chicago, then we have a origin set up at Chicago, and that's integrated with our login server. And then there's a series of caches. So these are servers that keep local-ish copies of the data. So like I said, somewhere nearby where it's actually executing. This system is integrated with OSPool and HT Condor job submission. It's actually fairly simple to use. It's a little different than the default transfer mechanism, but it's not too much more complicated. OSDF itself, the system as a whole, is operated by the OSG, so very much alongside the same infrastructure that we operate as part of the OSPool. So a lot of the same services are provided, or these services are provided by a lot of the same people as the OSPool. And in terms of what the OSDF is accomplishing here, in the past year, the OSDF has transferred more than 200 petabytes of data through this network, used by a bunch of people, a bunch of projects. It has a very high throughput rate of the number of files that are being transferred. So if you think about, the savings of the data that we're getting, for most of this data, there is some multiplier behind that corresponds to a bunch of other similar jobs that we're reusing that data from the local cache. And so, we were talking about, I mentioned earlier, if your average file size is, 1 GB per file and you're transferring 10 million files a day, that's 100 petabytes a day. So with the OSDF, we're getting a huge savings in terms of the amount of data that's being transferred, which allows the OSPool and users on the OSPool to run calculations that otherwise would be very slow just because they're always waiting for a file to be transferred. Instead, by reducing the network congestion, the volume of data that we have on the OSPool, jobs are able to start up much more quickly while still using a relatively large file. So a little bit on the practical details here of how do you actually use the OSDF as an OSPool user. So let's say you have an account on the OSPool and you want to transfer files using the OSDF, well, you can use that to transfer both input and output data. We will start by talking about the large input data. So on the OSPool, where you log in, your access points, there should be a directory in /OSPool/AP, whatever your access point number is, data/your username. Place your file in that directory, and then you use the OSDF plugin in your submit file. So it still uses transfer input files in your submit file, just like you do with your other input files. But now you provide this special syntax here, OSDF : 3 slashes, OSPool, and then the path to that file. And that's it. HT Condor, when you submit the job, when the job starts running, HT Condor and the OSDF system will automatically handle the transfer of that data when the job starts. So as long as you have the data in the right location on the access points, and as long as you've added this syntax to the transfer input files in your submit file, everything else is handled automatically behind the scenes. And there's a guide here on our website about how to use the OSDF. And it talks a little bit more about the system and some of its limitations, or what its capabilities is a better way of saying that. And I'll note here, with this setup, this default setup, only the OSPool user who placed the data will be able to use that data, unless we've worked with you to come up with some different scheme. This is the default. So that also means that system of caches, where the job actually executes, again, only your job will be able to access the data in that cache or in the original location of the data. So that's input data. You can also use the OSDF system to transfer output data. This doesn't use the cache system, but you can still use it for transferring large files. We still recommend using it to transfer large files because it moves the responsibility for the file transfer off of the login server and onto a different server. So again, in your submit file, you'll want to specify the files you want to have transferred. The syntax here is a little bit more complicated. So in transfer output files, you're saying relative to where the job was running in its temporary directory on the execution points, where's the large file you want transferred. Then you also have to use the transfer output remaps command. So the transfer output files is saying what is the file at the location of the job, and then the transfer output file, or sorry, the transfer output remaps is saying when you transfer that back, I want you to use the OSDF instead. So HT Condor will recognize this and know that the transfer is going to be handled by OSDF, and then you provide that same location on the access points where you have your input files. You do the same thing for your output files in this syntax. And then again, HT Condor and OSDF automatically handles the data transfer. So when the job finishes and it's in the transfer output step, HT Condor, OSDF will automatically transfer that file back. You don't have to add anything else to your submit file or any commands to your script. And again, that information is in the guide on how to use the OSDF on the OSPool. Okay. So next up is going to be Justin. He's going to talk about Pelican and how it's supporting the OSDF. Let's see here. So I'm going to let him share his screen, take over the slides.
You have a question from Stan, Andrew, for the transition.
Let's see here. Where does it output by default if you don't specify the output remap? So the default for transfer output files is it will be transferred back to the same directory the job was submitted from. And importantly, in this context, by default, it will not use the OSDF. So if you are transferring a large file, what that means is that HT Condor on your login server is what's going to be trying to transfer that large file. And if you have many jobs that are doing that, that can slow down the server as it tries to manage the transfer of the large file. So if it's a large output file you're trying to transfer, it's important to make sure you do the transfer output remap and tell it to use the OSDF. Okay, I'll hand it over to Justin.
All right, thanks, Andrew. So as Andrew mentioned at the start, my name is Justin Heemstra. I'm one of the Pelican platform developers, and I'm really hoping that with Andrew's first half of the talk, he's sold you on why Pelican's a good thing and why we should be using OSDF for some of the problems we face in distributed high throughput computing. But I think everyone would benefit from just kind of a bit of an explanation about how Pelican works, what it's doing, some of the underhood stuff. I won't get too deep into it, and some of the things we're working on to make the platform better for our users. So we'll start off talking about what Pelican is. At its core, Pelican is a software suite that aims to create and manage data federations. And if you think back to your middle school, high school civics class, the kinds of political federations you might be familiar with also apply to some of these types of things in computer science. So, the federation is the idea that you have a loose coalition of semi-autonomous entities that come together, maintain their autonomy, but they work together under some loose organization to accomplish some goals. And that's what we're doing in Pelican. So in this case, one of the core entities are the data owners, the people who have the data or put data into something like one of the AP directories. So one of the ideas here is that data owners can come and go as they like. So in Pelican, we say that if today you want to federate your data and make it a part of some public namespace so that other people can compute on it, or you want to make it a part of a namespace so that only you can compute on it, we let you do that today. And then if tomorrow you decide it's not my thing and I want to pull my data out of this system, you can do that. As a part of that, we make sure that the data owners, the people who are distributing their data, have the ultimate authority to choose how their data is being used and distributed. So when you add your data to a Pelican federation, you still get to decide who gets to access it, how they get to access it. We do this through a system of different types of authorization tokens that I won't talk about today, but if you have questions about it, we can certainly go into more detail. But suffice it to say that if you put data into the system, you're still in charge of it. And in fact, if you don't make that data public, nobody else in the federation can view it, not even the people who manage the federation. One of the other things that we try to get out of this is this idea of a unified namespace. So Pelican is able to take data from a variety of different types of backend locations. So in the case of something like AP40, all of that data lives on a POSIX file system, and Pelican's job is to take something off of that file system and move it throughout the federation. But we also support things like S3 and Globus and HTTP servers and some other things. So we design the system so that to a user, everything feels like it's coming from the same source. That is, you don't need to know whether or not the data upstream lives in S3 or POSIX or any of these other things. To you, it'll look like a file path. And then finally, through combining all of these aspects and by kind of creating this coalition of autonomous entities, we're able to kind of tackle bigger challenges. And that's what leads to the scalability, so that 218 petabytes in the last year isn't something that we could accomplish unless we had lots of people working on the problem and we distributed the work across the different entities in a federation. So that's kind of the concept there. Pelican creates data federations and it manages data federations. And you've probably heard Andrew and myself at this point refer to the OSDF and Pelican, and I want to try to distinguish those two terms. So the OSDF is an instance of a data federation. If Pelican's a tool for creating and managing data federations, the OSDF, the Open Science Data Federation, is one federation that we've created using Pelican. So just like htCondor is the software that allows us to kind of glue all of these distributed computing clusters together, and we call that cluster of computers the OSPool, the OSDF is a cluster of data services that are glued together by Pelican. And so we actually, we now have one other federation, aside from the OSDF, and that's the University of Wisconsin Data Federation. And in theory, you could walk away from this training today and maybe set up your own data federation to do some interesting things. So Pelican's a tool for creating data federations, and it really seeks to serve two different types of users. On the left side here, we have some kind of data repository that's a hard drive in your lab, or maybe the data lives in S3, or it's coming from an HTTP server. The point is that's where the data actually lives. And that's one of Pelican's primary users, is the person who owns data and has it stored somewhere and wants to make that data accessible to other people inside the federation. So these are kind of a snapshot of the different types of data backends we support now, but ideally we'd like to be supporting wherever you're interested in keeping your data. On the flip side of that coin, we have the people who use the data, who consume the data, who run computations on the data. And so it might be that you need to pull your data into a PyTorch instance to train some machine learning, or to visualize some images through your browser, or, as we discussed in the first half, you need to move your files via the OSDF for an OSPool computation. So the other side of this picture is that we have the clients and the data consumers. And often these two people are the same thing, right? So if you generate some file on an OSPool AP and you stick it in the special directory Andrew mentioned, you're both the person who is federating your data by putting it in that location, and you're also the data consumer, because presumably you're running an OSPool job that's going to do some computation on that. And so Pelican's job is, regardless of whether or not these two entities are the same individual, is to connect data providers with data consumers. And in doing this, we allow the dataset owners to federate their data from wherever it lives natively, and give them the ability to grant access to whoever they think needs their data, but then also to let the data consumers access and compute the data that's in the federation. So that brings us to kind of some of the core entities that are in a federation. And Andrew already mentioned origins and caches. And there are a few other terms that if you're working with Pelican, you're likely to hear. So I wanted to kind of give a quick run through of what each of these components are, roughly what they do in the federation, and which ones you might interact with as a data federator or a data consumer. So there are 6 core entities in the Pelican Federation. The first that we've talked about already is clients. So that's whatever tool you're using to access data through a Pelican Federation. In many cases, that's the HT Condor OSDF plugin, but Pelican also has a command line tool. We're working on a variety of other clients that I'll talk about in a little bit. So the tool you actually use to get and put data. Next is the data repository. And again, that's where the data actually lives. So at the end of the day, this is always a disk, whether or not that's on your computer or it's on someone else's cloud computer, AWS server or something. The data lives on the disk. And so these take the form of, again, POSIX file systems or S3 servers or things like that. So the origin piece that Andrew mentioned is kind of this special piece in the Pelican Federation, and it acts as a gateway that facilitates the transfer of data from whatever kind of repository it lives in, and allows it to move into the Federation space. So the origin is what allows us to take data from any kind of repository and get it to a cache or a client or anybody else who's trying to use the data. And in addition to facilitating that data transfer, the origin is also responsible for managing different types of access policies. So when you set up an origin because you want to federate some data, you can set up different requirements about who's allowed to access that data, how the data access has to occur, and some other things like that. So the origin facilitates movement and access controls. And then, as Andrew also discussed, we have the caching mechanism. So when you pull data through the federation, it gets plopped on a cache somewhere. And the idea then is that repeated use of whatever that data might be is sped up by not having to go back to the source of the data each time. And right now, this really is kind of a truly a caching mechanism. So you pull the data and it gets plopped there. But One of the things we're working on is also making this a staging mechanism. So rather than saying, I've launched my OSPool workflow, and the first time I grab some file from the OSDF, it gets stuck on this cache server. We'd like to be able to say, I'm going to launch my OSPool workflow, and I'll need my data ready in this cache by the time the jobs start landing there. So that's one thing to kind of be aware of. That's an upcoming feature. Next, I kind of mentioned when I was talking about federations that we have these discrete and autonomous entities that come together under some loose organizational structure. And in Pelican, that organizational centralized structure we call the central services, and it's made up of two components, the registry and the director. So the director's job, and hopefully we've picked this name to be somewhat self-descriptive, is to direct people, to tell them where to go. So whenever a client joins the OSDF and it says, hey, I need some file off of AP40, it'll go to the director and ask, where do I go to get this file? And the director's job is to know that information and have it ready and available so that it can send the client to the appropriate origin or the appropriate cache. And the other services in the federation also talk to the director. So the cache, if it doesn't already have a file, will kind of ask the director the same question: which origin do I go to get some piece of data? And then the origin talks to the director because it's constantly pinging the director and saying, hey, this is who I am, this is what data I have, this is how you can talk to me. And the idea there is that if the origin suddenly stops pinging the director, or it the server shuts down, or there's some kind of an error, the director will recognize it hasn't heard from the origin in a certain amount of time, and it'll stop sending people there. So that's one of the flexibility and scalability mechanisms that Pelican employs. And then finally, the registry is the part of the central services that deals with identity information. So when origins or caches join a federation, they have to tell the central services who they are. They give some information about public keys that allow us to prove that they are who they say they are in the future, and some of that stuff. So the registry is kind of this persistent store of who's who. So Pelican is a fairly new project at this point, and I'll talk a little bit about Pelican and the OSDF in another slide. But so we're working through our documentation, and we just got through another large revision. So hopefully, if any of these pieces didn't make sense the first pass, you can visit our docs, and there will be some nice pictures and graphics that explain things in a little more detail. And if they aren't nice and descriptive, let us know, and we'll update them. So that's kind of a broad overview of what Pelican is and what goes into a Pelican federation. But as I mentioned, we're pretty new, and while we're excited about making what we currently have more stable, we're also excited about bringing new features to users. And so one of the first things we want to focus on are the different types of clients that Pelican offers. I've mentioned that we currently have a command line client, so you can go and install this, and then from your terminal run things like Pelican object get that'll allow you to pull data from a federation. We also have the HT Condor file transfer plugin, which is the OSDF : / that Andrew mentioned in the first half. But we're working on a few new things. So the first of these that I'll mention is a file system specification for Python. And that's essentially a way that allows you to integrate into different Python environments and do things like, with open, and then provide a Pelican file and have that open natively, as opposed to using some other tool to download the file onto your local disk and then opening it in a standard way through Python. ML is in its heyday right now. There's AI craze everywhere. So of course we have to develop some clients that work with the different machine learning libraries. So we're currently working on data loaders for PyTorch that lets you iterate over Pelican data in an efficient manner. And then finally, we recognize that a lot of users are maybe not comfortable in command line environments and things like that. So we're also working on some, pretty web browser type clients that let you move and fetch data via a browser. So up to this point in the previous slide, you may have noticed some Pelican : / URLs. In Andrew's part of the presentation, we talked about the OSDF : / URLs. And I wanted to take a moment to kind of break down what these are and how we use them, because they're an important part of the way Pelican works. So in a typical URL, you've all typed http:// and hopefully now we're all typing https://. And the first part of that URL is what's called the URL scheme. And that defines basically the protocol. So in HTTP, it says, when you type http://, your browser knows, okay, this is how I speak HTTP to other HTTP servers. And so Pelican has defined this Pelican:// URL that tells Pelican clients, this is how I speak to a Pelican federation. After the scheme is the host name, and we'll talk a little bit about what these other parts of the Pelican URL do. So as I said, the Pelican:// defines a metadata lookup protocol that tells Pelican clients how to speak to a federation. The host name of the URL is the federation's host name, or the root. So in this case, if I were to ask you what is the host name or the root of the OSDF, it would be osg-htc.org. And that's essentially the place that we go to look up some metadata so that we can tell a list of all the other services that are a part of our federation. It's kind of the service discovery endpoint of a federation. And then the last part of the URL is the desired object or name. So in this case, we're trying to fetch an object called /weather/cloud.jpg. And this relates to the OSDF:/ URLs in a pretty simple way. OSDF:/ is just a shorthand for this longer Pelican:/ OSG-htc.org. So when you type in OSDF schemes, you're basically just avoiding having to type the rest of this stuff. And if you notice in OSDF URLs, there's this third slash that throws a lot of people off. And that's kind of why that third slash is in there, because this OSDF scheme translates to the first half of this, and then everything else is the name of the object that you're fetching. So things should still work if you do forget the third slash, but that's kind of why it's there. It's a part of the URL schema. And one of the nice things about using URLs to define different object names and to define objects within a federation is they let us interact with some other parts of URLs that are handy. So for example, we get access to query parameters. And a query parameter is anytime you see a URL that has a little question mark somewhere near the end of it. And it's basically a way of telling the server, hey, I have some more information or some context that I want to give you that should tell you how to process my request. And Pelican has defined three URL query parameters at the moment. So the first here is direct reads, and you can tack that onto your URL, and it tells Pelican, I want to skip all of the caching stuff. For whatever reason, I've decided I want to go straight to the origin and avoid my data winding up on a cache. So you can do that in Pelican with the direct reads query parameter. Similarly, we have the recursive query parameter, which is if your data, instead of large file, you have large directory, you can recursively download that directory or a collection of data, if it's an S3 prefix or something, using that parameter. And then finally, we have the pack query parameter, which lets you deal with kind of tarballs and some other packed data structures. So if I'm uploading a file to a remote location, and I use the pack equals tar.gz, it'll take the directory that I'm uploading and pack it up into a tar.gz and then transfer it to the remote location. And similarly, if I'm downloading and the remote file is a tar.gz, then I can unpack it on the fly using the query parameter. And so this is an example here at the bottom of how you would string one of these together. The only thing I'll note is that for direct reads and recursive, you don't need the equals true or equals false or anything. Just having this flag there is enough to trigger it. But when you use pack, you need to tell it the structure of that packed data so that Pelican knows what it should be trying to do with the packed data. So we're also working to make things in general more friendly to users who, again, don't live and breathe command line tools. And while we don't yet have a client that lives in the browser, all of the other servers that Pelican runs, so the registry, the director, the cache, and the origin, those all now come with a web interface that lets you do some nice things. So if we'll talk about in a minute how to host data through Pelican by spinning starting an origin. And when you start an origin, you can go to this web interface and do things like modify your configuration or monitor transfer speeds and some of those nice pieces of information. Okay, so that's, again, broad overview of Pelican and some of the pieces that we have in Pelican. You can also contribute your data to Pelican. So if you don't want to just kind of stick a file in an OSPool AP, you can actually run your own origin service that exports whatever data you need. And there are two ways to accomplish this. The first is you email us and you ask nicely and say, hey, I have some data that I'd like you to host in Pelican for me. And we can certainly do that. And then the alternative is for you to host your own origin. And this is kind of the ultimate, if you want to be hands-on and control your data and manage the way it's accessed, and you don't want to let the people who operate the OSDF peak or anything like that, you can do this, and then it's totally under your control. So hosting an origin is something that we haven't had too many people try to do on their own yet. And so we're hoping to find people who are interested in doing this, who want to add data to the Federation. And certainly if you decide to do that, you'll get the white glove service from us because we want to see you succeed in that. So currently origins, as I've mentioned, can host data from POSIX HTTP or HTTPS servers, S3, and it doesn't have to be AWS S3. So for those of you who don't know, S3 is a protocol, not just a service offered by AWS, and there are other people who host S3 instances too. And then we have this new experimental Globus backend. So if you have a Globus collection and you're interested in federating that, it's experimental, so we can work together on that. And the process of setting up one of these origins is relatively straightforward. If you've ever set up your own server, you install the Pelican software or you use a container. And most of the time, I think people are using containers here. You get a hold of some TLS credentials, and that's what gives you the little S in the HTTPS. Makes sure that the data to and from the services is encrypted, and we can verify that it's coming from where we think it is. You set up one of these configuration YAMLs, and this is kind of an example of a very bare bones configuration here on the right. So in this case, you'd point it at the name of the federation you want, tell it that you're running a POSIX origin, and then set up some of the different names and capabilities of the origin. And then you click run, and as long as you're on a server that doesn't shut down frequently and is open to the web, you've hosted your data through an origin. So that's a very brief overview of some of the steps. We have some more detailed setup information. And again, if you're interested in doing this, you can contact us for more information. So we do have a couple trainings coming up. If you're interested in hosting an origin, I highly encourage you to look into attending one of these. The first is coming up here in Madison. It's in Throughput Week 2024. We have a Pelican tutorial. But if you can't make that, we have another opportunity coming up at PERC 24, where you can learn some of the basics of running origins in Pelican, and this will be a hands-on session, so you won't walk away not knowing how to do it.